let's check out this tiling pattern here. If you think about your shower or your kitchen, you might have tile, and that means you just have the same shape, usually a square, right? And it's just repeated. There's no gaps, no overlaps. So we got this tile pattern here with this parallelogram. Let's see if we can find any angles that are congruent. If I take a parallelogram with our tracing paper here, and let's mark this angle right here. All right, can we find any angles within this parallelogram that match it? Okay, if I rotate this, okay, looks like this angle does not fit there. Okay, if we rotate it again. Oh yes, that does fit in that corner. So I can mark these two angles the same because they are congruent. Since these angles are congruent, I'm going to color them both in blue. To mark that angles are congruent, we're going to use a single tick mark to show that this angle and this angle are the same size. Let's check out this top corner angle. Is this the same size as the other one? We rotate it. Yes, it is. So we can denote those congruent. So we'll color these in green, and we will also mark that they are congruent angles.
Since these two green angles are congruent to each other, we are going to mark those with 2 tick marks so that we can distinguish them from these 2 angles.
Because this is a tiling pattern, we know that this same coloring, if I take it and I just shift it down, it's going to be the exact same for all of them. So we're going to fill that in. All right, so now this is what the tile pattern looks like when it's all filled in, and we are going to zoom in on a certain section of this tiling pattern to see if we can find any new relationships. All right, so we've got our tile pattern here, and we're zooming in on this specific section right here. So you can see an enlarged version with some notation here to help us refer to different angles within this section. So let's introduce a new vocab word called transversal. A transversal is a line that crosses 2 or more lines. So in this case, do you see the transversal? The transversal here is from J to K. So we'd say our transversal is JK. Which lines from this picture are parallel? All right, well, we know parallel lines are lines that will never cross into each other. They will never have an intersection point. So we would say our parallel lines are LN and NP. And again, you can write this arrow symbol on top of both of them to show that it's a line.
And the reason we can say that LM and NP are parallel to each other is because of these arrows that are labeled on them. If you remember from our last video, we talked about when there is an arrow on a line, that tells us that those lines are parallel.
All right, let's see if we can find any relationships within this diagram. Let's try tracing an angle and see if we can find any other relationships. Let's highlight angle X here on tracing paper. If we slide it along the transversal JK, and right here, it looks like X and B are congruent. We know that X and B are congruent angles because when we use our rigid transformation of translation to slide it up, that they were equal. You can also see that up here as we zoom in on our tiling pattern. This blue angle, if I were to slide it up, it would fit right here as well, and we know that those are congruent using rigid transformations, or you can also see that this angle and this angle are vertical angles, so they have to be congruent. A special name that we like to give angles that are in the same spot but on different intersections are corresponding angles. So X and B are considered corresponding angles because they lie in the same position at different intersections. Another way to look at this is X is in the top right corner of this intersection down here, and B is also in the top right corner of this intersection, so they are considered corresponding angles. You could also do this with D, and what would D correspond with? Since D is in the bottom right corner, it would correspond with the bottom right corner, so D and Z would match up. So D and Z are corresponding angles because they're in the same spot at different intersection points, and they are also congruent. So now we have a couple of examples of transversals right here. Let's see if our corresponding angles definition still works. So if I look at 135 and I slide it on over, yes, I know that X has to be 135. So we can say that these corresponding angles are congruent because if I use a rigid transformation to translate it over, it matches.
Okay, let's try this one right here. This angle is 135, and if I slide this over the transversal, it does not match up with this angle X right here. So why do you think that is? We can see on this example over here, these two lines are parallel. And because they're parallel, it allows us to slide over this angle and they'll be congruent. But when the lines are not parallel, when we slide this angle over, we do not have congruent angles. 135 still corresponds to X. They are corresponding angles, but they are not congruent because these lines are not parallel.
Because we know that these lines are parallel, then we know that X has to be 135 degrees as well because they're corresponding angles with parallel lines, so we know that they will be congruent. And X and Y are vertical angles, so we know that these angles are congruent, so we know that Y also has to be 135 degrees.
So because these lines are not parallel, we cannot say that X is equal to 135 135. But we can say what y is equal to because these two angles are supplementary. They add up to 180 degrees. So we can say that y is equal to 45 degrees.
All right, let's investigate another angle pair relationship when we have a transversal crossing parallel lines. So we got angle C here and angle X. These are called alternate interior angles. They are alternate because they are on alternating sides or opposite sides of the transversal, and they are interior angles because they are in between these parallel lines. So alternate interior angles are angles that are on the opposite side or alternating sides of the transversal, and they are in between those parallel lines. If I had a setup that looked like this, even though these angles are alternating, they would not be considered alternate interior angles because one of the angles is on the inside, but this angle is on the outside of the parallel lines, not inside the parallel lines. So this would not be considered alternate interior angles. Is there another pair of alternate interior angles you can identify in this picture? All right, we can see here that D and W, we can see that D and W are alternating the transversal and they're also inside those parallel lines. We know that D and W are also alternate interior angles since they fit this definition.
Now let's see what sort of relationship these alternate interior angles have. If we have this angle traced right here, let's see if we can get it to match up with angle X. So if we slide it down and then we rotate it, we can see that angle C matches up with angle X. So angle C and angle X are congruent. So with alternate interior angles, just like with corresponding angles, they're only congruent when these lines are parallel. If you look at this example over here, these two angles, they are alternate interior angles, but we can see that they are not congruent because these lines are not parallel. Another way that we can show that C and X are congruent to each other is by using our definition of corresponding angles and vertical angles. So if we take C, we can see that Y is corresponding to C, and Y is also vertical angles with X. So C and Y are congruent, and Y and X are congruent, so thus X and C are congruent. And we can see that with W and D as well. W corresponds to angle A, so W and A are congruent. And then A and D are vertical angles, so A and D are congruent, so W and D are also congruent.
All right, let's check out another angle pair relationship when we have a transversal crossing two lines. Let's look at D and X here. What name would you give these angles? Okay, we call these angles same side interior angles because they are on the same side of the transversal, right? D and X are on the same side of the transversal, and they're interior because they lie in between our two lines here, our two parallel lines in this instance. If I had a transversal set up like this, these are not same side interior angles. Even though these angles are on the same side, these angles are not both inside those parallel lines. These are actually corresponding angles. They lie in the same position, just at different intersection points. So this is, again, not same side interior because both angles are not inside those parallel lines. All right, let's see if we can find a relationship between X and D. I take X here and I slide it. We know that X and B are corresponding. And we see here that B and D are a linear pair, or they add up to 180. So we know B plus D adds up to 180 degrees. And since X equals B, I can swap out B for X, and I know that X plus D has to equal 180 degrees. So we know the relationship between X and D is that they add up to 180 degrees. They are supplementary, but only when the lines are parallel, right? If we had lines that weren't parallel, we cannot say that these alternate interior angles are supplementary because this and this, they are corresponding, but they are not congruent since the lines aren't parallel. So we cannot say that they add up to 180 degrees when the lines are not parallel.
Let's look at these set of lines here. Our goal is to figure out what X is. We want to solve for X. And to do that, we're going to have to use some of these angle relationships that we have learned. All right, so let's see if we can figure out how this angle up here, 4x minus 25, relates to 3x plus 10. So 4x minus 25, we know that it corresponds to this angle right here. Okay, we're getting closer. And then we also know that this angle corresponds to this angle. And because the lines are parallel, we know that when they are corresponding, they're also congruent. So 4x minus 25, this angle right here, is congruent to this piece, and then this angle is congruent to this piece. And then now we have vertical angles. So this angle is congruent to 3x plus 10. So since 4x minus 25 is congruent here and here, it's then congruent to 3x plus 10. So we can say 4x minus 25 equals 3x plus 10. And now we have an equation that we can solve. So we're first going to get all of our x's on the same side. So I'm going to subtract 3x from both sides, and I'm left with 1x, or just x, minus 25 equals 10. I'm going to add this 25 over here to make this a zero pair. I'm left with x equals 35 degrees. On your Derivita assignments, sometimes it might just say solve for x, and then you'd be done at this step. Other times they might say, okay, what is the actual degree of this angle right here? And that's when we take our x value and we plug it in. 4 times 35 is 140, and 140 minus 25 is 115 degrees. So this angle right here is 115 degrees, and this angle right here is also 115 degrees because they are congruent.
All right, let's check out this example here. Our goal here is to use our angle pair relationships to fill in all the missing angles here. So let's check out this 30 degrees right here. I know that 30 degrees, we have a vertical angle pair right below it. Remember, vertical angles are angles that are directly opposite of the intersection point. So I know that this one has to be 30 degrees as well. Okay, I don't really have anything else going on for me up here, so I will shift on down here to this 110. This is 110 degrees. I can see that this is a supplementary angle or a linear pair with this angle right here. So I know that if this is 110, then this has to be 70 degrees in order for this to add up to 180. So I know that this is 70 degrees. Let's try sliding this along this transversal here, see if I can find any other angles. So 70 degrees, as I slide it along the transversal, I see that it will fit right here because these two lines are parallel. I know that these are congruent. This angle also has to be 70 degrees because these are corresponding. Using vertical angles again, I know that this has to be 70 degrees as well because they are vertical. Another way I could have gotten this angle is I know that this is alternate interior angles with this angle. All right, now I have another supplementary angle going on up here. I got 70 plus 30, which is 100. So I know I need 80 in order to finish this line. So this has to be 80 degrees. And using vertical angles again, this one has to be 80 degrees. Because of alternate interior angles, I know since this is 80, this one also has to be 80. And then we can fill in the rest here. 80. Supplementary, this is 100 degrees, 100 degrees. And I can verify that this is 100 degrees because if I slide this angle up, it fits right here. And 70 plus 30 also adds up to 100 degrees. So I know that that works out. And then I can use vertical angles here as well to fill in the rest of our angles.